Aloha everybody, this is Gigi from Kauai Community College. In this video, we are talking about the limit at infinity and the definition of the horizontal asymptote. Okay, so I'm going to focus on the horizontal asymptote definition because that is related to limit at infinity, right? So the horizontal asymptote definition said, the line y equals some number a is a horizontal asymptote if limit as x goes to infinity of f of x is equal to a, or limit as x goes to negative infinity of f of x is equal to a. What it is saying is way out there on the right and way out there on the left, if your function is flattening out, meaning if your function has a limit, then that limit is your horizontal asymptote. Okay, the line y equals a is your horizontal asymptote. So, given that definition, when you are asked to find a horizontal or oblique asymptote, you really are being asked to look for the limit as x goes to infinity and the limit as x goes to negative infinity. Okay, so you are looking at limit as x goes to infinity of f of x, and you are saying, does that equal to some number? And then you are looking at limit as x goes to negative infinity of f of x, and then you say, does that go to the same number or a different number? It doesn't really matter. If it goes to a different number, then you have two horizontal asymptotes. All right, so let's go take a look at this function here. We need to look at limit. Let's first go look at the limit as x goes to positive infinity of this function. Okay, now this function has square root of 16x to the fourth power plus 64x squared plus this x squared on the outside, and then this right here, 2x squared minus 4. Okay, so the trick to this is when you go looking for limit at infinity, you are thinking the limit as x go into infinity of 1 over x, that is going to be 0, like 1 divided by a really big number, or a constant divided by a really big number is going to be a really small number. Okay, so you are relying on the fact that the limit as x goes to infinity of 1 over x is 0. That's something that we're going to go ahead and lean on for this type of problem. Okay, so here, in order to do that, we would go ahead and divide both the numerator and the denominator by the highest exponent. The question here is, what is that highest exponent? I see x squared, I see x to the fourth, but wait a minute, x to the fourth is inside the square root. So really is square root of x to the fourth is x squared. So x squared is your highest exponent, and x squared really is equivalent to saying square root of x to the fourth power. Okay, so we are really here dividing by the same number on the numerator and on the denominator. In other words, dividing by 1, and that's not going to change your problem. Okay, so inside the square root, when we divide by x squared outside of the square root, inside the square root, we really are dividing by x to the fourth power. And that's how that goes. So that then becomes limit as x goes to infinity of square root of 16x to the fourth divided by x to the fourth is 16 plus 64 divided by x squared plus x squared divided by x squared is 1, all divided by 2x squared divided by x squared is 2 minus 4 over x squared. So since a number divided by, and honestly, this right here, 1 over x, could have been 1 over x to the nth power, right? It's just denoting that a constant divided by a big number is going to be a very small number, and that small number is approaching 0. So when we look at this here, we will say this is going to be approaching 0 as x goes to infinity. And this is going to go to 0 as x goes to infinity. So we have this equals square root of, equals to square root of 16, which is 4. 4 plus 1 is 5. 5 divided by 2. So that limit is 5 over 2. Okay, so since the limit as x goes to infinity of f of x is 5 over 2, then we say the line y equals 5 over 2 is your horizontal asymptote by the definition. Okay, so now we should also go and take a look at what happened when you have x approaches negative infinity. Well, everything is going to be the same, right? And we're looking at the same exact function, reduce 64 over x squared. And does it matter if x is a negative number? In this case, really, the square root of x to the fourth power is always x squared. Square root of something is a positive number, and x squared is a positive number always. So we are okay to say square root of x to the fourth power is always x squared. And that is an okay thing to say even if x is a negative number. So this is still going to give you the same result. Which means, that would be minus, not plus. Which means you will have only one asymptote. This is going to go to 0. This is going to go to 0. So you still have 5 over 2. This is also 5 over 2. And so you only have one horizontal asymptote. And that is that. Now, what do I mean by saying square root of x to the fourth power is always x squared? What about square root of x to the sixth power? Is that just x to the third? Not always. You might be thinking, what? What do you mean not always? Square root is to exponent 1/2. 1/2 of 6 is 3, so it's x to the third. Well, it's x to the third when it's positive. What if x is a negative number? Okay, so really, in algebra class, we should have learned that square root of x to the sixth is not just x to the third, but rather the absolute value of x to the third, because square root of a number has a positive answer, right? Because we want that to be a function. Remember how the square root function goes? Square root of 0 is 0. Square root of 1 is 1, not 1 and negative 1, just 1, right? And then square root of 4 is 2, not negative 2, right? So when you have square root, you only have positive answer. So square root of x to the 6 is the absolute value of x to the third, meaning that has to be a positive number. Well, how does that change anything about limit, right? So suppose you have a very similar problem, but now instead of let's look at the limit as x goes to negative infinity of something that looked like this. Instead of 16x to the fourth, let's say 16x to the 6 plus 64x squared plus x to the third over 2x to the third minus 4. Okay, so the same trick will apply. We are going to go ahead and divide by the highest exponent to the numerator and the denominator, which in this case is x to the third, right? But we really want to divide it inside that radical also. So we are thinking square root of x to the 6, right? However, square root of x to the 6 is not just x to the third. It should be the absolute value of x to the third, meaning it is a positive value. Okay? Now, how does that change anything here? Let's take a look. Inside, when you divide by x to the 6, and outside, you divide by absolute value of x to the third, absolute value of x to the third, absolute value of x to the third. What is happening here? Limit as x goes to negative infinity. When you say x is approaching negative infinity, you are saying x is a really big negative number, right? It's a negative number. X is a negative number. So this right here, x to the 6 divided by x to the 6 is still going to just be 16. And then you have 64 over x to the second divided by x to the 6 is going to be x to the fourth power. Plus, what is this here? X to the third is a negative number. Absolute value of x to the third is a positive number. A negative number divided by a positive number is going to be a negative number. And a negative what? This is going to be negative 1 because the value is the same, but the signs are different. So that really is negative 1 right there when you divide. Same thing will apply on the denominator here. This right here is going to give you negative 1. So that is negative 2 minus 4. So this then is going to be square root. This is going to go to 0, right? Oh, this is not negative 4. This is going to go to 0, so that's not there. So that will just be negative 2 on the denominator. And then you have square root of 16 is 4. 4 minus 1 is 3. You have 3 over negative 2, which is negative 3 over 2. Okay, so with this function, when x is approaching negative infinity, it is going to go to 3 over 2, whereas if you were approaching positive infinity, then this part right here on the square root of, you still have 16 plus 64 over x to the 4th power plus x to the 3rd over absolute value of x to the 3rd. And this right here is 2x to the 3rd divided by absolute value of x to the 3rd minus 4 over absolute value of x to the 3rd. The same thing that you have. However, this right here is going to be positive 1 because both the numerator and the denominator are positive. Okay, so a positive number divided by a positive number of the same value is positive 1. So this right here is positive 1, right? So what you will have here is you will have on the numerator, this is going to go to 0. So you'll have square root of 16, which is 4, plus 1, which is 5. And then on the denominator, this is going to go to 0, and you will have 2, right? So when you're looking at the graph of this, however the graph look like, you know, on the right-hand side, let's say this is 1, 2, 3. This is 5 over 2 right here. On the right-hand side, you have 5 over 2, y equals 5 over 2, being your horizontal asymptote. Whereas on the left-hand side, you will have, this is 5 over 2, whereas on the left-hand side, 1, negative 2, this is negative 3 over 2 right here. On the left-hand side, you will have y equals negative 3 over 2 as your horizontal asymptote. So basically, your function is flattening out at 5 over 2 on the right, but flattening out at negative 3 over 2 on the left. Okay, so that is something that we do need to pay attention to. Square root of x to the 6 is absolute value of x to the 3rd. Okay, so whenever your answer is an odd exponent, it could be negative, so you have to put an absolute value to it. Whereas here, the absolute value of the square root of x to the 4th will just be x squared, and it's okay because x squared is always a positive number.